Okay, today we are going to learn about concept behind solving the points problem. Okay, so we know how to solve the points problem. So there is a concept here. So basically it involves three basic concepts. So based on these three basic concepts, we are going to solve the points problem. Okay, well, now we'll see what are those basic concepts behind solving the problems. So we can take concepts for solving points problem. So herein there are three concepts or conditions by which we can solve the points problem. So the problem is very easy. So first concept here is identifying the quadrant. So from the question we need to identify which quadrant it is. Okay. If I say an example, say if a point is lying 30 mm above HP and 20 mm in front of AP means it is in first quadrant. Okay. Like that, first thing is we need to identify which quadrant. Either it is an first quadrant or second or third quadrant we need to identify. So the first thing is we need to identify the quadrant. Similarly, you can say that if a point P is lying 30 mm behind of VP and 20 mm below of HP, that means in third quadrant. So that is the first concept. That means we need to identify the point is lying in which quadrant. Okay. Now second concept is writing the conventions for the identified quadrant. Say we have been identified it is an first quadrant. So what is that? The convention for the first quadrant means we need to write it in by means of xy with the VP HP. Okay. So this is the convention for first quadrant. Say we need to write it in terms of orthographic views. Okay. That's what writing the conventions for the identified quadrant. Say we have been identified. Say the point A, say 30 mm above HP, 20 mm in front of EP, it lies in first quadrant. Say if it is lies in first quadrant means with respect to first quadrant, so what is the convention for it? So that is our second concept. Okay, that is our second concept. So now we comes with the third concept, that is nothing but visualization. So visualization is very important concept. So now we will discuss deeply. So how a visualization will be. Okay. So now you understood, right? There are three basic concepts for solving the points problem. One is identifying the quadrant. That means we need to identify the point. Either it is lying in first quadrant, second, third or fourth. Next, with respect to the quadrant, we need to write down the conventions for it. Okay. That is writing in terms of HPVP with respect to the XY line. Now the third concept, it is nothing but visualization. Visualization means we will be seeing how we are looking the thing. Okay, how we are looking the thing. So that's what the visualization. So how we are looking the things from it. So we can able to define what is exactly the visualization is. Okay. So now we see what is visualization is. So in the visualization, this is a very important concept. So in the visualization, I will take bit by bit one of the each of the concept. So first take I define now a point is lying above HP or below HP means it is an front view. So what is this? If a point is lying above HP or below HP means it is an front view means it is based on the visualization. Say if I take this one, so this is our horizontal plane, correct? This is our horizontal plane. Say if any point, say consider this is our pen. If it is lying above HP or below HP means, so this point which is having certain distance from this horizontal plane, okay, say some 50 mm above HP or 30 mm below HP, this distance plus weave can be projected on the vertical plane, correct? So you can say that if any point, if it is lying above HP or below HP means it is an front view, because the distance from that particular HP plane, if it is above HP or it is below HP, it can be seen only from the front view. That's what visualization, how we are looking the things, okay. If the point is lying above HP or below HP means it is an front view, okay, because the point how much farther from this HP plane, say 50 mm, 60 mm above HP, can be seen from the front view. Similarly, a point is below HP, how much below of it, say 100 mm, 50 mm, 20 mm, how much it is farther from it, it can be seen only from the front view. That's why if any point lying above HP or below HP means it is an front view, okay. So understood. So now similarly we can write it for the second one, okay. If any point, okay, any point is lying in front of VP and behind of VP means it's an top view. So how it is? So second concept, say if any point, say this is our front, this is our vertical plane, correct? Vertical plane. If any point it is, say if it is lying in front of VP or behind of VP means this how much it is front or how much it is closer to it, it can be seen only from the top view, correct? Only seen from the top view. Say if any point it is lying in front of VP or behind of VP, it can only be seen from the top view. How much it is for, say 40 mm in front of VP or 50 mm behind of VP, it can be seen only from the top view. That's why it is an top view. You can see that if any point it is lying in front of VP or behind of VP means it is an top view, okay. So that's how we are going to visualize, okay. If any point here, point P, say it is some 50 mm in front of VP or 40 mm behind of VP, it can be seen only from the front view, okay. So now we all understood, right? This is how we can able to visualize, okay. Say I am going to repeat it again. If any point is lying above HP or below HP means it is an front view, because we are able to see the things from the front view. Similarly, if any point is lying in front of VP or behind of VP means it's an top view, because we can able to see the distance, how much it is nearer or farther from this vertical plane can be seen from the top view, okay. Guys, you understood? Today we are going to learn about basic concepts related to visualization. Okay, so in this we will learn a bit by bit. If a point lies above HP and on VP. Okay, so if a point lies above HP and on VP, you will be learning, you will be hearing this word on VP for the first time. So be remember, on HP means it is top view, okay. So above HP means we know that it is front view. So we need to find out what is front view, where the front view it is lying, okay. So we know that in quadrant system there are 4 quadrants, okay. So this is our first quadrant, second quadrant, third quadrant, fourth quadrant, okay. So you can see that if a point lies above HP and on HP, we already got the top view. Now we have to look for the front view. So above HP means, this is our HP plane, correct. HP plane is our vertical plane. So above HP means our point, the front view can lie in either in first quadrant or second quadrant. So that's what. So the front view, can write front view can lie in first and second quadrant. Okay, so the point will be lying, that is the point will be lying in first and second quadrant. Okay, now we'll see the second concept. If a point if a point lies in front of VP and on HP. So we know that on HP means it is front view. Okay, so on HP means front view. We have to see further. In front of VP means, so in front of VP means it is top view. So where the top view will be lying. So in front of VP means this is our vertical plane. In front of VP means there are two chances. Our front view can lie in first and fourth quadrant. That is, we can write. So top view can lie in first and fourth quadrant. So that is, point will be lying in first and fourth quadrant. Similarly, okay, if a point lies behind of VP and on HP. On HP means it is front view. So behind of VP means it is top view. So we have four quadrants. Vertical plane. This is horizontal plane. This is our first quadrant, second quadrant, third quadrant, and fourth quadrant. So top view behind of VP means there are two chances. The point may, the front view may, sorry, the top may lie in second and third quadrant. So I can write top view may lie in second and third quadrant. So that is, point will be lying in second and third quadrant. Okay, similarly, if a point lies below of HP and on VP. So and on VP means this is our top view. So below of HP means it is front view. Okay, so below of HP means we have to see it. So below of HP means two chances. The point may lie in third and fourth quadrant, that is front view. So we can write front view may lie in third and fourth quadrant. That is, point will be lying in third and fourth quadrant. So the point may be lying in third and fourth quadrant. Say if a point lies below HP and on VP means below HP means two chances, third and fourth quadrant. So the front may lie in third and fourth, that is finally the point will be lying in third and fourth quadrant. Okay. Today we are going to discuss problem of points on side views. Okay, so in this problem, so we will be dealing with the side views here. So we will go with the question. A point P is lying, P is 30 mm in front of VP, 40 mm above HP and 50 mm from RPP. Okay, so in this problem, so as we have know, so it involves three concepts. First, to identify the quadrant. So in front of VP, above HP means it is our first quadrant. So for the first quadrant, we know the notations. So VP, HP, XY. That means first we are going to draw this first quadrant top view and front view. Okay. Okay. So we know that 30 mm in front of VP means it is in front of VP means it is top view. So top view it is drawn in the HP plane. So 30 means three boxes and you put a point. So that is here the top view. Similarly 40 mm above HP. So 40 mm above HP means it is our front view. It is four boxes. It is P dash. So now we'll show with the dimensions. This is 40 mm and this is 30 mm. Now you can see this 50 mm from RPP. This is what the side view. So where it is exactly means in the quadrant. So you can see this. So this is our HP plane and this is vertical plane and this is our RPP, right profile plane. So this right profile plane it is adjacent to the vertical plane. Okay. So in this problem he is mentioning that a point P is 30 mm in front of VP and 40 mm above HP and 50 mm from the RPP. So this it will be there adjacent to the vertical plane. Okay, when it is drawn in the orthographic, so it will be like this. Okay, so front view, top view, this front view connected with the side view. Okay, so that means for this RPP we will be drawing another x1 y1 line at a distance of 50 mm. Okay, now to draw this side view with the top view we will be using 45-degree angle line. Okay, so you just follow the procedure. Okay, now from this projection point we have to consider a distance of 50, that is 5 boxes. Keeping this distance of 5 boxes, here we are going to draw x1 y1 line because it is 50 mm from RPP. So this is x1 y1 RPP, right profile plane. Okay, now we know that so side view will be there adjacent to this front view. So we draw a straight line. After this we know that we have to draw an 45-degree angle line here. Okay, in order to connect the top view with the side view. So that is 0, 10, 20, 30, 40, 45. So mark a point, then draw a straight line. This is your angle line, that is 45-degree angle line. Now from this top view, so we will be drawing a straight line until it touches the 45-degree line. Then we project upward. Okay, so where these two lines are intersecting, so this point is our side view. Okay, this is what the say, and we can show the direction of the projection line. Okay, so this is what the side view. Welcome to Engineering Visualization channel. Okay, today we are going to see problems on points problem. Okay, so as we have discussing the problems on points, okay, so it is one of the different type problem. You can see in this problem they have not given any kind of dimensions. Instead of it, so using the concept we have to solve the problem. Okay, you can see the question here. Draw and state the quadrants in which the following points are located. Assume any distance. That means the distance you can take any of it. Okay, you have to identify which quadrant each of these points are locating, and then you have to write it by assuming any distance. Okay, so you can see front view below xy line and top view above xy line. So it is third quadrant, right? So I'll write here only. It is third quadrant. Similarly, front view and top views are below xy line. So this is fourth quadrant. Okay, front view and top views are above xy line. It is second quadrant. Okay, front view above xy line and top view below the xy line means, so it is your first quadrant. Okay, so it is easy to write. So first I am going to draw one xy line here. Okay, so here they have not mentioned to take exact distance, so conveniently you can take any of the distance. Okay, first I am mentioning this, the point here. Okay, front view below xy line and top view above xy line. So front view below xy line means this, I'm taking convenient distance and I'll put a point. So this is a dash. Similarly, this is a top view above xy line. Okay, this is your third quadrant. In the same way, leaving convenient distance, front and top views are below xy line. So I'll be mentioning here. Okay, both on the same line. I'll mention B, B dash. Okay. Next, front and top views are above xy line. So above xy line means I'll give one as 30 and another will be on 40. So here C and C dash. Next, fourth line, that is a point number D, front view above xy line, front view. So here I'll mention front view. This is D dash and top view below the xy line. So here it is. So here we have assumed any of the distances. You can assume it. It is given in the question. Okay, so that completes the problem. Okay, you can mention, if you want to mention, you can mention here. A is in third quadrant. Okay, and B is in fourth quadrant. Okay, similarly C is in second quadrant and D is in first quadrant. Okay, so that completes the problem. You can subscribe for the channel and hit on the bell icon for the latest notifications and share it to the maximum students so that they can be benefited. Thank you all. Thank you for watching the video. Okay, today we are going to discuss another problem on LPP, that is a side view problem. So the first problem we have done with the right profile plane. So now we are going to do the problem with respect to the left profile plane. Okay, so we know the procedure. First, to identify the point is lying in which quadrant. The point is 40 mm. A point, you can say point B here. Okay, point capital B is 40 mm behind of VP and 20 mm above HP. So it is in second quadrant, behind of VP and above HP. So for the second quadrant, so we have vertical plane, horizontal plane lying above the XY line. Okay. So XY, another both vertical plane and horizontal plane lying above the XY line. Now 40 mm behind of VP. So behind of VP means it is top view. Okay, behind of VP means it is top view. So I'll be drawing here 40 mm. 40 mm means 4 box. So it is small b, top view. Now 20 mm above HP. So above HP means it is our front view. So on the same collinear line we can mention 20 means two boxes. It is b dash. So now we can show the dimension here. So it is 20. So it is 40. So now we have done with the both the top view and front view. Now we have to do the side view. So you can see this from 30 mm front, behind are from LBB. So that means from this projection we have to consider three boxes here. Okay, three boxes here, and we will be drawing a dimension line. Okay, that is 30. So here exactly leaving a three boxes, that is 30 mm, we will be drawing a projection profile plane, that is x1 y1 LPP, that is a left profile plane. Okay, so now we know the procedure. Where there will be a top view, we have to draw an angle line here. So we will be doing the same procedure. So intersection of these two lines here exactly, so we will be marking for 45 degree. Okay, so it is 45 degree. Now from this point, so we have to draw a straight line, and we know that with respect to the front view we have the side view, so that's why I'm drawing a straight horizontal line adjacent to it. Okay, so from the intersection of this point, okay, from the top view intersection to the 45 degree line, so we have to draw downward. Okay, so here at the intersection of these two lines, so we get an side view b double dash. Okay, so b double dash, so this is what the direction of the projection line. Okay, now in this question they have mentioned name the side view, which view it is. So it is a second quadrant. In second and fourth quadrant, so it comes to the, you know, that second and third quadrant comes under third angle projection. Okay, so it comes under third angle projection. So in third angle projection, what happens with respect to the LPP, we have left side view. Okay, with respect to the RPP, we have right side view. So this is left side view. So this is, we can write here, left side view. Okay, so today we are going to learn on a single point how two or more views exist in a points problem. So we are going to discuss. So you can see the question. A point 30 mm above xy line is the front view of 2 points. You can see in this question, a point 30 mm above xy line is the front view of 2 points A and B. Okay, for the 2 points A and B is mentioning the front view, that is A dash and B dash, it will be lying above the xy line at a distance of 30 mm. Okay, so that's what it is directly mentioning. So we will be proceeding with the question. Okay, how it's mentioning. So this is another type of problem. Okay, so in this problem he is mentioning 30 mm above xy line, as we will be proceeding with the question. So 30 mm above xy line, so we drawn 30 and we have put a point. So this point 30 mm above xy line, it is indicating front view of 2 points A dash and B dash. So we'll be showing the dimensions. Okay, so that is our front view. Okay, the single point which is indicating two views, and it is lying at a distance of 30 mm above xy line. We have done it. Now we have to see, this is what the front views. Now we have to see for the top view. The top view of A is 40 mm behind of VP. So you can see the top view of A. Top view of A is 40 mm behind of VP. So behind of VP means, there are two chances. So this is behind of VP. So either the top view can lie in second quadrant or it is in third quadrant. Okay, so we see in the third quadrant, so HP VP, so the top view is lying above the XY line, and third quadrant also HP, it is lying above the XY line. You can see in this, the point A is 40 mm behind of VP. Behind of VP means two chances, either it in second quadrant or third quadrant. In second quadrant also HP will be lying above the XY line, and in third quadrant also HP will be lying above the XY line. We know that the top view will be drawn in the HP planes. So that is, when you collinearly we have to draw the top view. Okay, already we have drawn 30. So we will be extending by 10 mm. Okay, so put a point, that is our top view. So 40. Okay. Now similarly, the top view of B is 45 mm in front of VP. So the top view of B is 45 mm in front of VP. So in front of VP means we know that there are two chances, either in first quadrant or in fourth quadrant. Okay, so in first quadrant, so where the top view is, so in fourth quadrant, so we know that HP VP lying below. So you can see this in the first and fourth quadrant, in both the cases the top view is lying below the XY line. So that means we will be drawing below the XY line 45. 45 means 4.5 marks. 1, 2, 3, 4, 4.5 marks. Here you have to draw till here. So put a point, and this is your top view. Mention with the dimension line. Okay, so this is what the problem of on a single point, two or more views. Okay, today we are going to learn about shortest distance problem in points. Okay, so they will be giving the shortest distance in this problem. So nothing but a arc distance we have to consider here. So in this type of problem, they will be mentioning about only one view. Okay, using the shortest distance, we have to construct all the three views. Okay, now we proceed to the question. You can see this is shortest distance problem. A point A is 20 mm above HP. Above HP means we know that it is front view, so we get it about the one view, and it is in the first quadrant. That means he is telling that we have to consider the first quadrant, that is VP above XY line and HP below the XY line. And then after that he is mentioning, and its shortest distance from the XY line is 40 mm. That means arc distance of 40 mm you have to consider to construct it, and then draw the projections, determine its distance from VP. Okay, so you all understood, right? In this problem they are mentioning only one view, that is front view, and then they have given the hint that we have to consider the first quadrant, and then they have given the shortest distance. So shortest distance means arc distance. So arc distance, that means we have to consider a compass here. Okay, so we know that it is an first quadrant here. So VP above the XY line, HP will be below the XY line. So we will proceed with the question now. y. So you can see this 20 mm above HP. So 20 mm above HP means, so it is in first quadrant. So HP VP we have written. Above HP means it is our front view. So that means I'll be drawing the front view first. So 20 mm is 2 box. Put a point, that is A dash. Okay, so 20 mm it is done. Now you see that, so it is in first quadrant, its shortest distance from the xy line is 40. That means shortest distance from the xy line is 40 means we have to consider here, so x1 y1 line, okay, means from that intersection of that x1 y1 profile line we have to draw an arc here. Okay, so for that we have to consider a scale here, and we have to consider 40 mm. So take compass and measure 40 mm means 4 centimeter. So from this point to here take exactly 40 mm. Okay, so from this intersection point of this, okay, from this intersection point of this you draw an arc. Okay, after drawing the arc mention the radius, okay, r40. So mention it r40. So after this what we do, after drawing an arc, so from this front view we will be drawing a straight horizontal line, okay, as it is intersecting this point arc. So this point is nothing but our side view, that is a double dash. Okay, now we have to draw an top view. So for that what we do, so here in this case we will be drawing an 45-degree angle line. Okay, all the three views you have to draw it. So for that we'll be drawing 45-degree angle line, 40 45. So we can mark a point here. Okay, so this is our 45-degree angle line. Okay, now we can draw from this side view a vertical line until it touches the 45-degree angle line, and then draw, and from this point you draw an straight horizontal line. Okay, okay, you know that the front view and top view are there in a straight collinear line. So we'll be drawing a straight vertical line here. Okay, so where these two lines are intersecting, this point is our top view. Now we can measure the dimension because it is mentioned in the question. You can see that draw the projection, determine its distance from VP. So we need to measure. So it is around 39 mm. Okay, so it is around 39 mm. So you can mention 39 mm. So this is what our shortest distance problem. Let us see different type of problems in points. Okay. Now you see 2 points RS are on HP. So R on HP means we know that these are front views. Okay, so front views are on HP means these front views will be there on the XY line. Okay, so 2 points R and S are on HP means, so these are front views. So these front views will be lying on the XY line. Now we see the point R is 35 mm in front of VP. Okay, so in front of VP, so R is 35 mm in front of VP. So in front of VP means two chances, first quadrant and fourth quadrant. So in first quadrant, so in front of VP means we know that this is top view. So VP HP below the XY line. So here XY HP VP. So in both the cases, so this R top V, it is lying below the XY line. Okay, so now we will draw the first the top V. Y. So first I'm going to draw this top V R 35 mm below the X line. 35 means here 3.5 bucks. 1, 2, 3, 3.5 bucks. So till here. Okay. So the point, this is small r. Okay. So small r top V. This is 35. So we know that 2 points R and S are on HP, means these are front views. We know that top and front view it is collinearly joined. We know that front view of R, it is there on the XY line. So that is R dash. Okay, R dash. Now we will proceed. While S, you can see that while S is 50 mm behind of VP. So now see for the S. Sorry. Now we will see for the S. S is 50 mm behind of VP. So behind of VP means two chances, the second and third quadrant. So second quadrant, so what happens in the second quadrant? Behind of VP means these are top view. So VP, HP, so above XY line in the second quadrant, and in the third quadrant also. So we get HP and VP. So in both the cases you can see that the top V, okay, the top view of S, it is lying above the XY line. Okay, so we know that we can draw, we have to draw here above the XY line, but before that you see the line joining their top views makes an angle of 50 degree with XY. Okay, line joining with their top views makes an 50 degree with XY. So this is our top view from this. So the top view, yes, will be exist somewhere here. We have to draw and 45 degree and 40 degree angle line. Okay. So mark for 40. So from this point, just draw a straight line. Okay, just draw a straight line. Okay, we know that we know that the top view of S, that is top view is lying 50 mm behind of VP. So behind of VP means it is lying above the XY line. So for that purpose, what we do, we will be drawing an 50 mm 1 2 3 4 5 50 mm line here. Okay, 50 mm line. Okay, 50 mm horizontal line, 1 2 3 4 5. So 50 mm horizontal line. So that is nothing but locus of S. That is nothing but locus of S. Now we see that, so where this intersection of this 45 degree angle line with respect to this 50 mm, so we have drawn this. Okay, 50. So where these two are intersecting, this point is our the top view of S. Okay, top view of S. So collinearly, if you drawing downward, so this point is nothing but the front view of S dash. Okay, now we have to find out the distance here from this point to here. So horizontally find out. So the distance of this is around 101 or 2 mm will be, okay, 1 or 2 mm. Okay, so this is what the problem, and here it is an angle 40. Okay, welcome to engineering visualization channel. Okay, now we are discussing problems on points here. Okay, so it is one of the different type problem. It is a combination of 2 points A and B. Okay, so now we look at the question here. A point A is 30 mm in front of VP and 40 mm above HP. Okay, and it is and another point B is 20 mm behind VP and 35 mm below HP. The horizontal distance between the points measured parallel to XY line is 60 mm. Draw the three projections of the points. Okay, three projections of the points means here both top view, front view and side view. Okay, join their front views and top views. So we have to join both their top views and front views. Okay, so now first I am going to draw an XY line here. So this is X, this is Y. Now first we take the point number A. So point number A, what the information is 30 mm in front of VP and 40 mm above HP. Okay, 30 mm in front of VP and 40 mm above HP means it is the first quadrant. So 30 mm in front of VP means, so here I will be constructing 40 mm above HP means it is a front view. Okay, front view I am going to construct here. Front view we always got above the XY line here. Okay, so this is front view A dash. So you can show the dimensions also. It is 40 and 30 mm in front of VP. So in front of VP means it is the top view. So top view we getting below the XY line. So 30 means 3 boxes. Okay, and put a point. This is your A. Okay, this is 30. So top and front view of the point A is done. Now point B is 20 mm behind VP. Behind VP 35 mm below HP. Below HP means it is the third quadrant. Here behind of VP. So behind of VP means it is the top view. So here the top view we are getting above the XY line here. So here before that you can see here they have given one information here. The horizontal distance between the points measured parallel to XY line is 60. That means, so in order to before drawing the point number B, we should consider a horizontal distance of 60 mm here. Okay, here I'll mention with the dimension line. Okay, this is 60 and here we have to construct. So you can see 20 mm behind of VP. Behind of VP means it is the top view. So top view in the third quadrant we are getting above the XY line. So here, so this point is top view. So this is B. I'm showing the dimension line. This is 20. And same way 35 mm below HP. So below HP means it is a front view. So in the front view in the third quadrant we are getting below the XY line. So 35 means 3.5 boxes. See, this is 1, 2, 3. 3.5 means till here we have to extend. Use the scale or the box, no problem. You'll get the same length. Okay, this point is B dash. So this is done. So both top views and front views are done, and it is shown with a difference of at a horizontal distance of between the distance it is 60 mm. That is also done. Now, so the horizontal distance between the points measured parallel to x value is 60. Draw the three projections of the three projection means you can see this is front view, top and front view done. Now we have to draw the side view. Okay, side view we have to construct. So for this purpose, what I'll do, so we need to draw 45-degree angle line. First, for this point A, so the top view we are getting in the, so this is our top view, correct? This is top view and this is front view. So wherever we have the top view, on that side we have to draw the 45-degree angle line. Okay, so here I'll draw one x1 y1 line. This is x1 and y1. I'll use the protractor here. Place it at the intersection of xy and x1 y1 and mark for 45-degree and then draw an angle line. Okay, now from this top view, so draw the projection line till it touches the 45-degree line and then project it upward. Okay, and then project has a projection line here also. Okay, so this is the point where we get the side view, A double dash. You can see always with respect to the front view we'll get the side view here. Okay, adjacent to it we'll get the side view. Okay, in the same way now we have to construct the side view of this point B. So you can see here the top view here, this is the top view. So top view here we're getting above the xy line, that means we should construct the angle line. So I'll take this as the reference only, x1 y1 line. I'll place the protractor here and mark for 45-degree angle and then draw an angle line here. Okay, and you can mention this angle here, it is 45-degree. Now project the line, that is projection line from this top view we have to draw, remember it, till it touches the 45-degree angle line and then project it downward till the B dash end. Okay, till here and then project it from here also. Okay, so this is our point, this is our side view, B double dash. Okay, this is our side view. So both the side views and side views of both point A and point B it is done. Now join their front views and top views. So the front views, front view of A is here and front view of B is here. So I'm going to join their front views and top views with a straight line. I'm going to do that. Okay, and then joining their top views also. Okay, so this completes the problem. Okay, you can subscribe for the channel and hit on the bell icon for the latest notifications. Okay, and share it to the maximum students so that they can be benefited. Thank you all. Thank you for watching the video. Today we are going to learn about basic problems on projection of points. Okay, basic problems. Point A is lying at 30 mm above HP and 20 mm in front of VP. Draw the projections. So we have discussed there are three concepts in solving the projection of points. So first concept is to identify which quadrant. We know that if a point is lying 30 mm above HP and 20 mm in front of VP, that is above HP and in front of VP, it is an first quadrant. Okay, so now we have identified the quadrant. Now second concept is to write the notations in terms of xy line. Okay, you know that for first quadrant the notation it is VP will be above the xy line and HP will be below the xy line. So these two things are over. Now we are going for an doing in sketch. sketchbook. Okay, so now you can see in this sketchbook each of these units, it is equal to 10 mm. Okay, the length, width, everything here, each box, it is of dimension 10 mm, that is 1 centimeter. This is 1 centimeter, this is 1 centimeter. Okay, so first initially we are going to draw an XY line. Okay, that is the reference line. XY, VP, HP. Okay, this is an reference line. Okay, this is reference line. Okay, now we have to do the problem. Now we take one by one. Okay, a point A is lying at a distance of 30 mm above HP. We know that if any point is lying above HP, okay, if we know that if any point is lying above HP or below HP, means it is an front view. Okay, so the front view will be drawn in the vertical plane. So vertical plane, it is lying above the XY line. So initially we draw 30 mm. So 30 mm means 3 box here. So we can count the 3 box. Directly draw a projection line. Okay, we just draw to this line. Okay, projection line. So this projection line has to be thin. Okay, so we need to draw a thin projection line. Okay, drawing 30 mm, and you have to put a point. Okay, so this is an front view. Front view means it is A dash. It is A dash. Now we can show with the dimensions. Okay, this is 30. So similarly we have to write the top view. You can see that a 20 mm in front of VP. We know that if any point is lying in front of VP or behind of VP. Okay, behind of VP or in front of VP means it is top view. So it is 20 mm. So 20 mm means exactly we can count the 2 box and draw a straight line, and we can put a point here. This is our top view. We can show the dimension line. Okay, this is 20. Okay, so now we have done with the first problem. Say we calling these two lines as projection lines. These are views. Okay, these are views. This is front view, is also one view. This is top view. Okay, so now we have done with the first problem. Similarly, now we will write the second problem. Point B is lying at 20 mm above HP and 30 mm behind of VP. Draw the projections. Okay, here also we follow the same concept. First we will identify the quadrant. So here we know that if a point is lying above HP and behind of VP, means it is an second quadrant. So we know that for the second quadrant, if it is written in terms of XY line, both vertical plane and horizontal plane lying above the XY line. Okay, now we draw the first we draw an XY line. So both VP and HP lying above the XY line. We know that if any point is lying above the HP means it is in front view. So first we draw in front view. If a point is lying above HP means it is front view. So we put a point here. This is B dash. Next 30 mm behind of VP. So behind of VP means it is also behind of VP means it is top view. We know that all these views are falling in a same collinear line. I'll be extending 10 mm. Okay, so it will become 30. This is top view. Now we will show the dimension line. So this is 20. Okay, and similarly this is 30. Okay, on the same collinear line, we calling this collinear line. On the same collinear line we get the views here. Okay, top view and front view. So this is we have done with the second problem also. Now we will move to the third problem. Point C is lying 30 mm below HP and 30 mm behind of VP. Draw the projections. Okay, so we need to identify the quadrant first. So below of HP and behind of VP. So that means this is an third quadrant. Okay, we have identified the quadrant. Now we have to write the convention for it in this third quadrant. So HP will be above the XY line and VP will be below the XY line. That it is nothing but reverse of the first quadrant. Okay, so now we represent in 2D. So initially we draw an XY line. So HP, VP. Now we have to draw the views. So 30 mm below HP. Below HP means it is, we know that in a concept that if a point is lying above HP or below HP means it is in front view. So front view will be drawn in the vertical plane. So in the vertical plane we have to draw 30. Draw a line and put a point. This is C. And show it the dimensions. Okay, now similarly we have done with the top view. Now we see similarly write 30 mm behind of VP. So behind of VP means it is top view, correct? Behind of VP means it is top. So again 30 mm line. So we know the top view will be drawn in the horizontal plane. Okay, so now we have done with the third problem. So similarly can go for the fourth problem. Point D is lying 40 mm below of HP and 30 mm in front of VP. So draw the projections. Okay, now we have to identify which quadrant it is. So below of HP and in front of VP means it is an fourth quadrant. Okay, so point D is lying fourth quadrant. We know for the conventions both vertical plane and horizontal plane lying below the XY. Okay, and draw XY line here first. Both vertical plane and horizontal plane below HP. Now 40 mm below HP. So below HP or above HP means it is front view. So we draw the front view first. That means 4 boxes and you put a point. So this is D dash. Okay. So this is show with the dimension. Okay. Now 30 mm in front of VP. 30 mm in front of VP means it is top view. So we know that both the views are lying on the same collinear line. So this is our top view. Okay. So this is what we have done with the solutions of all the basic problems. Okay, today we are going to start the first problem in points. Okay, so we'll take the first problem. Draw the projections of the following points on the same XY line, keeping convenient distance between each projectors. Name the quadrants in which they lie. So first one, point A, 30 mm above HP and 35 mm in front of VP. Point B, 35 mm above HP and 40 mm behind VP. Point C, 40 mm above HP and on VP. Next point D, 35 mm below HP and 30 mm in front of VP. Okay, so this is the problem. Say the basic problem which you have solved, it is only the one point on the XY line. But you see in this problem, draw the projections of the following points on the same xy line. That is, on the same xy line we need to project all these 4 points A, B, C, D on the same xy line. Okay, by keeping convenient distance between each projectors, and after that we have to name the quadrants in which they are lying. Okay, we need to mention either A is lying first quadrant, B is lying in which quadrant, and C is lying which quadrant, and D is lying which quadrant. So that thing we have to do it. So first we are going to draw an xy line. Okay, first we are going to draw an xy line. Okay, herein you should not write VPHP. Okay, should not write, because there are 4 points are lying on the same xy line. Okay, so now we'll take one by one. First we will take point A. Okay, you can see the question. A point A is lying 30 mm above HP and 35 mm in front of VP. So above HP and in front of VP means it is an first quadrant. Okay, it is in first quadrant, right? So in first quadrant we know that. Okay, for your reference purpose I will be writing. So for first quadrant VP will be above X line and HP will be below the X. After drawing the projections we will erase this. Okay, so 30 mm above HP and 35 in front of VP, it is in first quadrant. So we know that 30 mm above HP, above HP means it is front view. So front view will be lying in the vertical plane. So we draw 30 mm means 3 boxes, and you put a point. So this is A dash. Similarly, so 35 mm in front of VP. 35 in front of VP means it is top view. So 35 means 3.5 box. Okay, 35 means 3.5. 1, 2, 3, 3.5. Okay, 3.5 box you have to mark. Okay, and you put a point here. That is your top view. Now you draw an dimension line for showing the dimensions. Okay, so this is 30 and this is 35. So now we have done with the point A. Similarly we look for the point B. So 35 mm above HP and 40 mm behind of VP. So above HP and behind of VP means it is an second quadrant. So point B is lying in the second quadrant. So after finishing this, you just have to rub it. Okay, remove this VP and HP. For reference, for your understanding purpose, you can write initially, then you can rub it. So 35 mm above HP and 40 mm behind of VP means it is second quadrant. We know that in second quadrant both vertical plane and horizontal plane are above the XY line. So 35 mm above HP means it is front view. So first we draw for 35, that is 3.5 box. Okay, and you put a point. Above HP means it is front view, B dash. Next 40 mm behind of VP. So it is in top view. Already we have drawn 35. So I will be extending by 5 mm. And you put a point. Okay, now we can write the dimension line. So this is 35, and here you can show it for the 40. So it is 40. Okay. Okay, now we have done with the 2 points. Now point C. So 40 mm above HP. Okay, 40 mm above HP and on VP. So as we have discussed in the previous concept, so and on VP means it is our top view. Okay, it is our top view. So above HP means, so here above HP, so we know this concept. So HP VP. So above HP means the point may be lying in first and second quadrant. Okay, first and second quadrant. So the point may be lying in first and second quadrant. You can see that already we have completed the top view. Now above HP means it is front view. So now we have to look in for the front view. So front view in first and second quadrant. See, in all these cases you just see in the first quadrant, so where the front view is lying. Okay, VP HP. So front view lying in the vertical plane, it is above HP. Similarly in second quadrant also you have to see for the front view. So front view here also it is lying above the X view. So in both these cases front view is lying above XY. Okay, so front view is lying above XY. So first we draw a front view. So front view of, that is 40 mm above HP, it is in front view. So front view it is lying in first and second quadrant. In both the cases first and second quadrant, the front view it is lying in the vertical plane. So vertical plane it is lying above the XY line, and similarly in the case of second quadrant also vertical plane is lying above the XY line. In both the cases the front view will be projected on the vertical plane. That front view will be drawn above the XY line. Okay, so that's why you'll be drawing 40 mm line, 40 mm line, that is 4 boxes, and put a point. So that is front view. Okay, front view okay, 40 mm. Now so we have this point on VP. So on VP means we know that it is in top view. So on VP means we need to project this point, that is top view, on the XY line. Please remember it. On VP means it is top view. This top view has to be drawn on the XY line. So okay, so here the point will be the point C. Okay, now similarly we will look for the point D. So point D is lying 35 mm below HP and 30 mm in front of VP. So it is in fourth quadrant, correct? It is in fourth quadrant. So below HP, 35 mm below HP and 30 mm in front of VP, fourth quadrant. So we know that in fourth quadrant both vertical plane and horizontal plane are lying below the XY line. Now we see, so below HP which it is in front view. So first we will draw in for front view. So that is 35, and you put a point, that is D dash. Okay, now similarly we have in front of VP. In front of VP means it is a top view. So here in both the cases it is projected below the XY line. I will put a point here, 30 mm. So it is top view D. Okay, now we are going to project it, draw with the projection line. Okay, so this is what, after drawing this, we'll erase these things. Okay, we'll erase these things. So this is we have written for our convenience. Okay, Okay, now we have to write down. You can see in this question we have to name the quadrants. Okay, we have to name the quadrants in which they are lying. Now we have to write for the first one, point A. So point A, you can write here. A is lie in. A is lying. We know that it is lying in first quadrant. Okay, A is lying in first quadrant. Similarly, for the B, we will write B is lie in second quadrant. Okay, B is lie in second quadrant. Similarly, C is lie in. You can see that C is lie in first and second quadrant. Both the things you have to write. Okay, because front view it is lying in first and second quadrant. So we will consider front view as a reference for writing it. So here in the point C, it is lying in first and second quadrant. Lying in first and second quadrant. Similarly, for the point D, we will write. So point D is lie in. So point D lie in. We know that it is lying in the fourth quadrant. Okay, it is lying in the fourth quadrant.